going on, everyone? Welcome back to the channel. Today I'll be showing you another tip in Python to improve the readability and efficiency of your Python code. And I think this video is especially useful for you guys to pay attention to because I think a lot of people will definitely learn something new in terms of the Python programming language, even intermediate people. This is something I learned just recently, and I've been 2 years in the industry and I've been coding for a few years now. And that thing that I learned and we'll be going over in this video is actually called the assignment expression, also known as the Walrus Operator. Now, this is a new syntax introduced as of Python 3.8 to solve a long outstanding problem in the Python programming language that can cause code duplication. And that problem we'll be going over in this video and showing how to make better with this operator here. So whereas a normal operator, as you can see here, where A equals B, we're just assigning A equal to B. With the Walrus operator, how it looks is we have A walrus B. And the reason it's called A walrus B is because this operator looks like a walrus with two eyes and then the tusks here. So that's just a funny tidbit there as to why it's called A walrus B. Now, just more info on terms of why the operator is useful. It's because this operator not only allows you to evaluate or assign A to B, but it also allows you to evaluate it in expressions such as if conditions where you couldn't do that sort of operation before. So the premise of the assignment expression is that you can assign and evaluate on the same line of code. And if that sounds a little confusing, it'll make a lot more sense if you go through this video and watch what scenario it's particularly useful for. And the scenario we're going to be going over is just some hypothetical scenario here in this block of code below. So in this example code here, just to demonstrate the use of this operator, what we have is a juice bar where we have some juice in stock, or some fruits in stock, sorry. So we have pineapple, strawberries, and kiwis. And a customer is coming by to ask whether we have pineapples or pineapple juice in stock. And so on our end, what we have to do is we have to check if we have pineapples in stock at our juice bar. So we do that in this line of code here where we access the dictionary and we get the value of pineapple in the dictionary. If there is a value, we assign it. Otherwise, we assign it as 0. And then if we do have at least one pineapple, we make the customer pineapple juice. Otherwise, we tell the customer that it's sadly out of stock. So that's just some hypothetical scenario. And this problem with this seemingly simple piece of code is that it's actually a lot noisier than what it really needs to be. So the count variable is actually assigned only within the first or before the first block of the if statement, and it's only used once in the first if expression. So defining count above this if statement makes it appear a lot more important than what it really is, as if all the code that follows is perhaps dependent on count. So you can imagine this is a really complicated juice bar, and we have a bunch of hundreds of lines of code that have logic for handling different scenarios. So me assigning counts outside of this if statement can make it seem that it's dependent in other parts of the code. So this can lead to maybe some confusion or less ease of readability in your code. And even in this whole scenario of fetching some count variable and evaluating in some if-else condition is actually a really common flow of code in Python, and many programmers try to work around this with multiple references and with a variety of other techniques that can actually hurt the readability of the code. So thankfully the Python community realized this, and they created this assignment expression to deal with this sort of scenario. So now I'm going to rewrite this expression. As opposed to getting the counts and then evaluating it, we can actually assign the counts and evaluate it within the same line of code by using this count walrus operator. So we're going to say count walrus fruits in stock dot get pineapple. Okay, so we're just going to copy that there. Oops. There we go. Oh my god. Okay. And then we're just going to delete this. We're going to save that. And then we have exactly the same thing that we did before with one less line of code. And we potentially increase the readability of the code by not making count seem like it's this universal important variable that may be used in the rest of the code. So if I go ahead and run this, we actually don't need this anymore. We'll see that we're going to make pineapple juice because we have pineapple. So let's just say print made juice. Okay, so perfect. So we just printed made juice and we evaluated and assigned count within the same line of code. We saved a line of code and just improved the readability of the code. So that's just one example of a really common workflow where you can use this operator to save some lines of code and improve readability. Let's try another example scenario where this can prove even more useful. Okay, actually, before I get into that example, let's just talk about another use case here. Let's say our pineapples are not that watery, and we need more than, let's say, one pineapple to make pineapple juice. So what we do in a typical scenario, as you saw before, we would get the count. We would say count equals this guy over here, right? So let's go back to the previous situation, and we say if count is greater than 1, we can make pineapple juice. We need 2 pineapples now. Okay, but once again, in that scenario, it doesn't have to be 0. We can use the Walrus operator once more. So let's go back here and use the Walrus operator to do that. So we can say if count, and then we actually have to put it in a sub-expression because now it's a sub-expression, is greater than or equal to 1. Now we can make pineapple juice with these drier pineapples. So if I go ahead and run this once again, we can make pineapple juice. So it doesn't necessarily have to be just a count of 0. You can use it for more advanced expressions, and it can prove useful once again. So if I go ahead and run that, we can say we made pineapple juice with these slightly less juicier pineapples. So that's just another example or a sub-example of the first example that I showed. So going into the last example of where this operator can be useful in this video is this particular example here. And this goes back to one of the frustration that programmers who are new to the Python language actually have often, and that's the lack of flexible switch case statements that you see in some other languages that make code a lot cleaner than it is, as you can see in this scenario, which we'll be going over here. So in this scenario, what we have is we have a more complicated juice bar where we have a customer who comes by and they have a preference of kiwi juice and then strawberry juice and then pineapple juice. So what they do when they come by the juice bar is they first want to order kiwi juice. So we first have to check if we have enough counts. So we have to check the dictionary for a kiwi, and if we have 4 or more kiwis, we can make kiwi juice. And then if we don't have that, we switch and we check if we have enough strawberries because that's the customer's second preference. So we do the same thing. In that case, we need 5 strawberries to make strawberry juice. And if we don't have 5 strawberries, what we check finally is the last preference, pineapple juice. If we have at least 1 pineapple, we can actually make pineapple juice. Otherwise, we just tell the customer we're out of stock, sadly. So if I go ahead and run this, which I already did before, we'll see that we'll tell the customer, unfortunately, we don't have enough ingredients. Now, this type of scenario is actually, once again, really common in Python, and it can be cleaned up really nicely by using the Walrus operator. So this is just another use case. So if I go ahead and do that in this scenario, what we'll do is we'll just say count walrus this guy. And then we have to surround that in parentheses. Okay, so we limited that code. We just saved 1 line of code. Nice. Now we could say else if, and we can say count. Let's just grab this whole thing, put it in some parentheses. So we're already cleaning up a lot of code, as you could see. And we'll say greater than or equal to 5, and we'll do the walrus operator again. So evaluates and assign, and then we'll just delete this. Once again, we're saving more code. That's beautiful. So once again, we'll bring this back because we removed that nesting there. And then once again, we'll say else if, and then we'll do the same thing here. We'll just copy this guy. We'll throw it in here. We'll do this. And we don't actually have to say greater than or equal to anything because it's just a 0 in that case. We only need 1 pineapple. So we'll save that. Now, in that case, we'll make pineapple juice. Okay, nice. And then finally, else, we'll just do this. So look at that. We just really cleaned up this code beautifully there in that nested if control statement structure that we had, and we could run this and get the same thing that we had before. So that's a really powerful instance to use the Walrus operator. So I'll go ahead and run that. You can see we got the exact same thing, and we saved a lot of lines of code. So hopefully, after watching this example and watching the previous example, you got a nice high-level overview of how to use this operator, where to use it, and where it can improve the readability and efficiency of your code. And hopefully you learned about a new operator, which I did recently, and I thought I'd share that with you guys. So if you did enjoy this video, you learned anything new, please like, comment, subscribe. Let me know what you want to see in the comment section below. And as always, guys, thanks for watching. Take it easy and stay tuned.